For our IDE, we'll be using an online IDE called REPL-IT, which you can get to by searching for REPL-IT Java. And we want this top link. If you have an IDE available to you, like IntelliJ, you can completely use that, and it would actually probably be better because IntelliJ has nice keyboard shortcuts and has better debugging features. But if you've been having trouble getting IntelliJ to work, there's nothing wrong with this IDE as well. Here you see the normal structure we're used to with a public static void main and a system.out.println hello world. And you can run your program by clicking run. You see it takes a minute for it to compile and then run. And I promise that it should display hello world at any minute. Okay, and finally there it is. So that may have gone faster on yours or slower on yours, but it's nice just to know what to expect. Okay, so let's start off organizing our game using if statements, but then very quickly we'll restructure it to the better approach that I mentioned. So a lot of the reason for doing this is to make sure that we can do things like get user input. So let's say instead of hello world, let's say welcome, you see a path left and right. And now we'll want to get user input. So if you remember from before, we had several ways of getting user input. Because this is a text adventure, let's use scanner. So with a capital S, type scanner. And input will be the name of our scanner variable. And then we'll create it by running the constructor new scanner with a capital S. And you have to type system with a capital S .in. So right now it's underlining in red because it says it doesn't recognize that expression. Oh, except now it does. I wonder if it imported it by itself. Well, we'll find out in a second. So then after printing the welcome message, let's get user input. So I'll call it response1. And I'll say input dot next string, or no, sorry, next line, let's say. So what will happen is we'll display this message, and then when the code reaches this line, it will pause and wait for the user to type something and hit enter. And then whatever they typed gets saved inside response1. So let's go ahead and test out what they typed. This won't be part of the game, but it's always nice to make sure that the small amount of code that you've just added actually works when you run it. So I'm going to click run, and we'll see what happens. So it looks like it's saying it cannot find the symbol scanner. So what that means is that we didn't import it. In IntelliJ, you could automatically import. For REPL-IT, you have to type the import statements yourself. So let's type import java.util.star. And that includes the scanner that we're interested in. So let's go ahead and run it again. And now we see welcome. You see a path left and right. And then I can type something like go right. And it says you typed go right. Okay, so we know that much is working. So let's modify this a little bit. Instead of a print line statement, which will go to the next line after displaying, let's use print. Or no, let's use print line, but then let's present them an option on the next line. System.out.print. And so now I'm printing this little caret, which will look just like the little caret down here, which indicates that they're supposed to type something. So let's also add the if statements. So if response1 dot equals. You might remember that when you're testing numbers, you'd use the double equals sign. But because it's a string, we want to type dot equals, and then inside parentheses, the thing that we're testing for. So this would be a way to test to see whether their response is equal to the word right. And if it is, let's type system.out.println. You go right. Otherwise, if response.equals left, you go left. Okay, let's test it again to make sure that much works. So I've used the word response, but actually my variable is called response1. Okay, so welcome. You see a path left and right. Do you want to go left or right? And let's type right. And now it says you go right. Okay, so we have at least some of the basic elements that we'll need. We can display things, and we can get user input, and we can test to see what they typed. Let's make a couple of improvements. Let's run it again, and you'll see that this code behaves okay as long as you do exactly what it's expecting, but it's a little fragile in other ways. So if I type right with a capital R, now it doesn't say anything because it's looking to see if response1 is exactly equal to this lowercase word right. Let's reveal another possible fragility. I'm going to run it again. If I type the words go right, now, again, it doesn't display anything at all. One easy way out of this problem is to restrict what they can type. So you could say type 1 to go left, type 2 to go right, and then all we have to do is change this to 1 and 2. And that will fix most of your problems. If you wanted to make it a little bit nicer, we could do this. Let's leave it the way that it was. Only we're going to do two things. We're going to say response1 equals response1 dot to lowercase. What this does is it takes whatever they typed and it forces it to become lowercase. And then we save it back over top of their old answer. So now we've destroyed what they originally typed and replaced it with a lowercase version of what they typed. So now that'll take care of the problem if they accidentally capitalize left or right. This is still going to evaluate to be true because we are only looking at a lowercase version. Another thing we could change is instead of testing whether response1 is exactly equal to right, we could test if it contains the word right. So instead of equal, type contains. And that should fix the other part of the problem. If we run it, you'll see what I mean. Now I can type in all caps go right, and it still does the right thing because it's forced this first to the lowercase, and then it's testing, does the entire string that I type anywhere contain the lowercase word right? And the answer was yes, and so it went in the correct direction. The only thing to be a little bit careful about is you have to make sure that the choices don't have possibly the same word, or they're not going to type something that's possibly the same word, because then it won't know which of the if statements to pursue. Well, it will pursue the first one. Anyway, let's continue. Before we can actually code further, I think now's a great time to jump into the other way of organizing. So we'll need to do a little bit of thinking work before we can do any programming work, which is pretty normal for a large project. So let's think about how we could reorganize to use objects that would let us have a more flexible structure than just if statements.